So I'd like to jump right in and start by showing you an example of what's sometimes called a brain-to-brain interface. I'm going to play a very short video clip for that purpose, where we get to see a person using their thoughts to control the hand of another person. So let me just set that up.
During the experiment, I'm wearing a cap for a procedure called electroencephalography. The short form for that is EEG.
On our side, we first map the part of the brain that controls my right hand, and this part is actually on my left part of the head. Then we use this machine to generate electrical fields.
The researchers work on opposite sides of the campus and through the internet. Rao, the sender, sits in front of a computer game in which he has to defend a city by firing a cannon. Stocko, the receiver, with no ability to see the game and his hand positioned over a touchpad that will fire the cannon, waits for a command directly from Rao's brain.
Yes.
Okay, okay, so in case that wasn't very obvious, what that experiment did was use the EEG to pick up brain waves associated with an imagined hand movement and to send that signal over the internet to this other machine that stimulates the brain of another person in such a way as to generate that hand movement. So what we saw at the very end of that clip, which kind of wasn't very impressive from that angle, was the sender, deciding now is the time to fire that cannon, and then the receiver, who can't see what's going on in the game, suddenly finds that his hand flicks to hit the keyboard and shoot down the incoming aircraft. So not particularly impressive, perhaps. It's a very convoluted way of getting someone to do something fairly simple. I mean, I guess the Luddite in me sometimes sees this and says, you can just tell them when to fire, when to press the space bar. But as you can imagine, depending on how that kind of technology evolves and unfolds, it raises all kinds of interesting questions about, mind control and merging minds and hive minds and all sorts of themes that, science fiction famously loves to deal with, and which technology is increasingly coming closer to realize. So what I'd like to talk about here is mostly what's called brain-to-brain interfaces, and to walk you through some of the ethical questions they raise. And towards the end, I want to fast forward a little bit to a hypothetical future where this technology has really come along and can allow for something akin to genuinely merged minds, or a collective mind, if you will, and to consider what that would mean for us, and for how we typically think about ethics. And I'll flag a disclaimer here about what example of applied ethics this is, right? So this is what's sometimes called anticipatory ethics, or slightly pejoratively speculative ethics, right? So it's looking at a technological trend and thinking, ooh, if this technology really takes off, it's going to open a whole can potentially of dystopian worms that we're not prepared to deal with, and so we'd better race ahead and get clear on what's at stake, so that we are in a better position to regulate these technologies as they emerge. And I think that can be a fine endeavor, but there's a sense in which it's a bit of a gamble, because there's a risk of expending a lot of energy thinking about something that, for whatever reason, never comes to be. But I think engaging in some anticipatory ethics can still be useful to directing our attention to the present in useful ways. And by the end, I hope to have conveyed what I mean by that exactly. Okay, so let's take a closer look at another example of a more collaborative brain-to-brain interface. So this is a really interesting experiment set up by this team from University of Washington, where they present this multi-person, non-invasive direct brain-to-brain interface, where you have 3 people using an interface called BrainNet to play a game that is sort of resembles Tetris, but sort of even more simplified. Unfortunately, there's no video for this, but it's worth trying to briefly walk you through the setup, so that we we have a concrete-ish understanding of the status quo of this technology. So the way it was set up was you had two participants who were considered senders, right? So their brain signals were recorded using an EEG and then decoded and translated and sent to the third person in the network, the receiver. Now, the senders who are in a different room to the receivers, they could see the whole Tetris-like game, right? They could tell whether an incoming block needed to be rotated or not. Okay, so the receiver could also see the incoming block, but not whether it needed to be rotated or not. So the receiver couldn't see the whole game, right? Just the incoming block. And what the senders had to do was tell the receiver whether the block needed to be rotated, again, because they could see the whole game. So once they made a decision about whether an incoming block needed to be rotated, that was picked up by the EEG and was transmitted via pulses of what's called transcranial magnetic stimulation, right to the receiver's occipital cortex, right, the part of the brain associated with vision. And so if the senders wanted the receiver to rotate the block, the receiver would actually perceive just a little burst of light in his or her field of vision, right? It's called a phosphene. So based on whether they see that signal in the visual field, the receiver then decides whether or not to turn the block, which is also controlled with their thoughts. So it's, again, pretty convoluted, but hopefully that broadly made sense. What was particularly interesting here was that in some trials of this experiment, the scientists complicated the setup even further by taking turns with each of the senders, right? So if one of them wanted to, they could, as the sender, send the wrong signal to the receiver, right? And the idea there was to see whether, over time and use, the receiver would determine which of the two senders was more reliable in the information they sent, and that way the setup would resemble a little more an actual collaborative effort, where sometimes we just don't know whether to trust our collaborators. So again, this is a highly contrived setup. It's not clear why anyone would want to play this game for fun. So it's not meant to be practical, let alone entertaining for the user, but it is a proof of concept for using brain-to-brain interfaces that allow for cooperative problem solving, using what the authors themselves call the quasi-social network of connected brains. So yes, this is a far cry from mind reading. But that same research team and a host of others are already exploring just a host of other more sophisticated brain imaging techniques to pick up more complex information like concepts and motions and desires, and then using brain stimulation techniques to elicit those concepts or feelings in the receiver's minds by stimulating different parts of the receiver's brain, depending on the information being transmitted. And as you can imagine, there are certainly a multitude of technological hurdles and limits to our neuroscientific knowledge more generally at play here, but it's an area that's been receiving literally billions in funding over the past decade, and there seems to be a lot of excitement about its potential. But it's not actually immediately obvious what the potential is. So let me consider some examples. So in a medical context, right, these kind of interfaces could presumably help people who cannot communicate for whatever reason, like locked-in patients, for instance, or individuals who have severe speech impediments. This could help them communicate with others, although in those cases, you don't necessarily need a brain-to-brain interface. You can just use what's called the brain-computer interface. And there's a lot of examples out there of experiments where, for instance, paralyzed patients learn to control a mouse cursor on a screen with their thoughts to spell out what they want to say, and then others could read that. Although I suppose with a brain-to-brain interface, that could make the communication potentially, much richer and more direct and seamless. But where this is likely to be most to garner the most interest is in collaborative setups, right? So it's no surprise militaries are very interested in this stuff. The idea of having, a live mental feed into the status of fellow combatants and to seamlessly communicate vital information very quickly. You can see why that might be useful, if a little disturbing. But similarly, you can see this being used in team sports and in gaming and research, and even just the process of thinking. I mean, if you consider how we tend to brainstorm just amongst ourselves, like the moment you try to think creatively, I assume a common experience we all have is that we kind of, formulate an intention in our head. So you might think, okay, well, what's a good name for this book I'm writing or this business I'm starting? And we then kind of wait and see what our minds come up with, right? Sometimes we're just met with frustrating silence. Sometimes it's just a terrible idea after terrible idea occurring to us. But subjectively, it's this process of kind of waiting for things to occur to us, to strike us or dawn on us. But the promise of a highly advanced brain-to-brain interface or brain-to-brain network is to have that creative process connected, for instance, to a powerful AI that links you to a network of other brains and which feeds you the best ideas from that network, kind of like how search engines work right now, except it's a network of connected brains rather than websites. Similarly, you can imagine how it might radically change how we learn new skills. For instance, you can imagine on top of trying to follow the instructions of your piano instructor may also be sending signals to that part of your brain associated with fine motor movements and stimulating it in ways that facilitate your ability to move your fingers in ways much more quickly than you otherwise would be able to. I say piano, but in principle, it could be, riding a bike or shooting a basketball. And of course, you can imagine it being used, socially and in relationships in all sorts of ways. And it's interesting to consider this, especially in the context of intimacy. So at the moment, some of us might appreciate, for instance, receiving, say, a random heart emoji from an intimate partner that kind of just says they're thinking about us, for instance. With some sophisticated brain-to-brain interface setup, you can imagine, your partner would visualize themselves, say, giving you a hug or a cuddle that gets picked up by the interface and sent over, and suddenly you feel like you're being hugged or big spooned or something, perhaps right in the middle of a meeting, which would be very distracting to say the least. But all these potential uses that I'm describing, they're to varying degrees anyway, not likely impending. But the job here, as I kind of flagged at the outset, is to anticipate the ethical issues. And I'm sure as I listed these examples, many of you were already thinking about all the terrible ways this can be used and how it might backfire. There's a great little side story in Douglas Adams' Hitchhiker's Guide to the Galaxy, where we learn about this advanced civilization, these Belcerebans, famous for being very calm and quiet and all enlightened, but they were deemed by other civilizations in the galaxy as quite smug and self-righteous. So they were punished by having telepathy enforced on them, on the entire civilization, so that all their thoughts are being constantly broadcast. The comedic effect being that, after being so calm and quiet for millennia, now they have to continuously talk out loud about the most inane things to try and stop all their thoughts being broadcast to others. Presumably because their thoughts were often mortifying. So let me sketch this, perhaps a bit of a caricature, but I think actually a very typical way ethicists approach these kinds of prospects. So let me sketch how we might start to think about the ethics of all this. So you have these things we care about, right? And this is by no means an exhaustive list, but we care to varying degrees about autonomy, privacy, authenticity, responsibility, justice. And often what ethicists will do is they take these values or concepts and kind of slap them onto a technology and see what happens. And that can be a valuable initial exercise. So autonomy, obviously, we can have a whole debate on what we mean by that exactly, but very broadly, it presumably relates to having some kind of control over yourself and your life. It relates to some kind of self-governance, so that minimally you are at least free from arbitrary control of others. And you can see how brain-to-brain interfaces may ostensibly cause all sorts of problems if on the one hand, as participants, our neural data is being recorded and transmitted widely among some network, including perhaps the corporation or the government that is running that network. So, there's that question of, will users know what kind of neural data is being recorded and who has access to it, and what the risk of it being, say, stolen or sold to other parties might be. And of course, that's all tied up with privacy. We tend to care about privacy because without it, we might risk losing some of our autonomy. At least that's one way of thinking about why we value privacy. On the receiver side, do you have control over what is being beamed into your head in terms of the mode and content and amount being sent over? Is there a risk that you may find your brain being stimulated in ways that give you ideas or desires whereby you can't even tell that they're coming from someone else, right? They just seem to be like your own. And that, of course, raises all kinds of questions about authenticity, right? So is this sudden desire to eat, say, a large pizza your own, or is someone on the brain network you're connected to trying to mess with you for some reason? Or is it someone working at Domino's, taking advertising to the next level? And then if you do decide to act on a desire while part of this brain network, are you responsible for that action, right? And will we be able to tell? Will we be able to tell where, for instance, that desire really originated from, or who contributed to it? And that's not even to discuss issues like brain hacking, right? So that video we just saw where someone willed another person to move their hand effectively, even if a brain-to-brain interface is intended for a very limited purpose, is there a risk it could be hacked whereby you might find yourself, strangling yourself or being made to pick your nose in the middle of a Zoom meeting as part of some kind of prank or something like that? I mean, that would be kind of funny, though. I'm not sure I'd appreciate it. And of course, you can ask bigger picture questions, right? Like, who has access to this technology? What key opportunities are the people who don't have access missing out on? Is there a duty to ensure everyone has access to it? And if the benefits turn out to be huge, should it be obligatory for everyone to access it, as we do with things, for instance, like primary education? These all kind of come under this umbrella term of justice. So there are all kinds of ways we might think about this, but notice, I mean, we're talking in very general terms here about a very nascent technology. And when we're doing applied ethics, the devil is almost always in the details. So, how does the technology work exactly? If we don't have that information, we can't meaningfully assess the risks involved. And all we can really say will be fairly on the abstract side, which I don't think would make it useless, but it'll be likely, one or two steps removed from being of much use to informing regulation. So one thing we can do when lacking that kind of detailed information is to ask how unique these very general issues are to the technology, right? And that way, you can at least start to see if there's perhaps already a framework in place for similar issues that might be helpful. So for instance, we might ask, is there something about neural data? Is neural data in fact more sensitive than general health data that, say, the NHS has on us, or that some wearable health tracking technologies have on us? Would neural data tell more about us to, say, corporations than all the data collected through cookies via the websites we choose to visit and the things we look for or purchase online? Which is to say, how far might we be able to map on the online privacy debate or the health data privacy debate onto this topic? What might the disanalogies be? So that would be sort of one rabbit hole we could dig down as a sort of way to see what might be at stake here. Similarly, we might ask, is there some fundamental difference between having a desire for a pizza arise in your mind because someone sent it over there telepathically, as it were, is that different from it arising because you happen to see an advertisement for a pizza on TV? Or, sorry, what, and if so, in what way exactly is it different? Are ideas or desires that are elicited through advertisement or just through what someone in the room said, are those in some sense more authentic than ones that are more directly kind of beamed to your conscious experience? And to what extent, is a more general question, to what extent are we already manipulated and in a sense hacked by all kinds of environmental stimuli, to do and buy stuff we might not or otherwise want to do or buy? Still, all very general, kind of vague question, but they're the sort of questions that might help us start to develop some kind of framework for thinking about what really might be at stake here and what might be novel or unique when it comes to brain-to-brain interfaces and collective mind technologies. And I actually think that these technologies probably do present novel ethical challenges. I think what is morally unique about brain-to-brain interfaces or collective mind technologies is that probably unlike other technologies, they have the potential to put pressure on what it even means to be autonomous or authentic or responsible, and to put pressure on why we should even care about these things. And the reason for that is because much of, generalization, but I think I feel kind of safe making it, which is that much of modern, broadly Western secular ethics tends to operate on the assumption that the individual is the ultimate kind of relevant unit of moral concern, right? The individual as this discrete, separate entity is at the core of our frameworks for thinking about ethics, right? Individual people are rational beings, and we have duties to them as separate from ourselves, with their own values and their own desires and goals, and figuring out how to navigate this landscape of separate individuals with separate goals and desires that often conflict is what modern secular ethics is, at least in large part, about. And so we come up with things like, don't use others as a mere means to your own end, because that wouldn't respect their agency, or that you should treat other individuals as you'd have them treat you. We codify ideas like the right of the individual to pursue happiness and the right of the individual to their own beliefs and so on. These are the ways we're trying to resolve ethical questions while taking into account that we are all separate individuals rather than ants in a colony or something. But what is unique about these emerging collective mind technologies is that they open the door to diluting what an individual is. So in the world we currently live in, it seems sorry, I'm just catching up on these. Yeah, it seems easy to say, this is my decision and that is your decision. This is my desire, that is your desire. This is what I believe, that's what you believe, which is precisely why we can talk about things like autonomy and privacy and authenticity. But and this is where we sort of jump to a more speculative future where fairly advanced brain-to-brain interfaces exist, and where we are communicating not so much with words and gestures, but more directly with feelings and desires and dispositions. In that hypothetical world, we might start to find that this very basic idea of me as opposed to you starts to break down, especially if that communication is so seamless and rapid that we can't even necessarily tell whether what is occurring to us in our own minds is coming from other individuals or not. In that hypothetical context, it's not clear what autonomy is. What does the self in self-governance amount to exactly? And why would you care about privacy or authenticity when more and more of the things that make you you are in this coalescent state with other people's characteristics? So that hypothetical future makes me think there is something unique about the potential of collective mind technologies, because they carry this prospect of diluting the idea of the individual as we tend to understand it. And the individual currently sits at the heart of modern day morality. So how should we think about this? I mean, if there is an option to join a hive mind, as it's sometimes called, and live in a society where it's just not clear what you're talking about when you say my autonomy, then there's this question like, well, what other values can you appeal to in order to decide whether it would be good to join this hive mind, right? Because usually when we think about things like that, we think, well, would it be good for me? Would it be good for me to move to the UK or to Mars or whatever? Except in this context of a hive mind society, that's not necessarily a meaningful question. And there's a great paper exactly on that question for those of you interested. It's worth reading. It's called In Defense of a Hive Mind Society, which questions some of our intuitions about why most of us find that idea quite terrifying. And I think that what I find most interesting here is that, we may never get the technology developed to that point. There may be many reasons, not just technical, but social, political. But this exercise in looking at what such a hypothetical technology might entail for concepts like the individual, which relate to things we care about, like autonomy and authenticity and responsibility, that exercise can allow us to look at or explore these concepts from a new light or from a different vantage point. So, up until now, sort of historically speaking, ethics has been able to take it for granted that we are stuck as separate individuals, right? And because of that, we haven't really had the need to think about why we should value that separateness. It's just a kind of a brute fact of the world we live in. People have their own separate beliefs and desires and so on. But if technology might allow us to quite literally close the gaps between individuals, kind of dilute those boundaries, suddenly we actually need to think about what is at stake exactly, and to be able to articulate the core rationale behind certain individualistic values. And I don't mean individualistic values in a derogatory sense or like a pejorative, but just like individual-centric values rather. And that's a useful exercise because depending on what we uncover, it could have significant implications for other things we care about right now that are linked to things like autonomy and responsibility. And so, yeah, if you have any. Thanks.